Hey guys, this is Shobit back with a new video on getting started with STM32 series where we'll be learning, building and enjoying throughout the process. I will be sharing my knowledge, experiences and difficulties with you which I went through while I was learning and help you out with some tips and tricks so that you can learn this tech stack as soon as possible. So whether you are completely new to this technology or microcontrollers or processors itself, you don't have any programming background or you do have some experiences, well, this series is going to have a lot of projects, a lot of examples, and a hell lot of fun. So without delaying, let me introduce myself. I'm Shobit and I'm a third year undergraduate student at College of Engineering and Technology in Instrumentation and Electronics Engineering background.
Well, it's situated in Bhubaneswar, Odisha, in eastern India.
Alright, so without any further ado, let's get started. So, embedded systems with STM32. An embedded system is a computerized system that is purposefully built for an application. And if you are from Arduino background, then you are quite comfortable with microcontrollers and using them and building your own small projects. Well, you might be knowing the fact that in embedded system, we deal with limited resources. We have limited processing, we have limited memory, we have limited peripherals. Alright, so in order to maximize the output from these limited resources, we need to optimize the code and use them correctly. Okay, now let's take a look what are the programming languages that are being used in the industry. So first of all, we have C and C++. Specifically, according to the standard, we will be using C11 throughout the tutorials initially. And we can also program these boards using Rust. I have seen a lot of good articles by industry experts, and I will give the link to their work to the Medium and LinkedIn profiles. Well, we can also program these boards with Java, and if you know assembly language, which is quite powerful. All right, so we can also program them using the infamous Micropython, which has become quite popular after the release of the latest Raspberry Pi Pico. And if you haven't seen our latest video on it, do check it out and do not forget to like, share, and subscribe the video. All right, we have another rival, that's the Arduino. We all know that. So a question might be ticking in your head that why should I choose Texas Instruments or STM32 over Arduino, or which one is better, or what should be my motivation to learn this technology? This can be a quite long video and I will make it in detail in some other day. So first of all, the major reason that Arduino is good to get started with microcontrollers and make small projects, but it hides a lot of backend information. Like for example, whenever we want to blink an LED, so what do? We provide a function that's a digital write pin high, then provide a delay, then make that pin low, and again we provide a delay and put that in a loop and it continuously runs and our LED blinks. All right, but what goes behind that? So if you want to see, just check out the code for the STM32. You can find some things which are not familiar to you right now, but don't worry, these are quite simple and it is nothing but register level programming. Whenever you go to an industry and want to become a real embedded systems engineer, then you will be working with quite frequently with their custom boards or the manufacturer like Analog Devices or Texas Instruments, wherever you will be employed. So they won't be giving you examples to that. So you need to go through the data sheets over and over again, through their reference manuals, and understand yourself, try and error, debug yourself. All right. So what are we gonna learn? First of all, we will be learning the basics of embedded C. So if you are from C, having a background in C language very well, or any other programming language, you can grasp it very easily. These are pretty simple. We are just using the C language in order to access the registers of the microcontrollers and manipulate them. All right. So I will be also giving some video series and basic concepts on data types, variables, scope, storage class, and functions. Along with that, we will be also getting to know simultaneously about the microcontroller of ST. All right. So I will be also discussing you the embedded build process, how we are going to use the pointers to refer register level addressing, Then I will be discussing the importance of operators and qualifiers, structures, which is very important concept. We'll be using bit manipulation to set, erase, extract data from pins and bits. All right. Then, as I'm from electronics background, I can help you with getting idea about some analog and digital electronics, which you might need at some places while you are learning this tech stack. Then we will move on to creating projects with STM32Cube IDE. This integrated and development environment is Eclipse based, and the later one, which is the Cube MX, it will help you generate some auto generated code for the microcontroller. So initially we will be using the former one to understand the concepts. Then we will move on to the later one to save our time. Well, this video series will be having a lot of examples, not only concepts. We will be moving from mini projects to bigger integrated ones, to like control systems, sensor fusion. So it will give you an intuition that how you can build your own project using your microcontroller. Then the later tutorials will include general purpose input output peripherals, UART peripherals, I2C, SPI, timers, real-time clock, and then I will also be giving you some debugging tips. We will also discuss interrupt management, DMA, and advanced topics like RTOS and power management too. All right, so next moving on to the software requirements. According to me, two softwares are must have for you and two are additional. So the must have first one is the STM32 CubeID and the QMX as said earlier. The next one is GNU compiler. It should be installed in your PC, and I will show you all the installation procedures later in this part of the video, or I will give the link to the description box below. Then additional are the Arduino IDE and Proteus 8. Why I am telling you that? Because sometimes some students don't have the resources or microcontrollers and electronic components, so they can use Proteus 8 in order to simulate the environment, as well as we can also program these microcontrollers with the help of Arduino IDE. Yes, it's possible. We have to integrate library from ST, which is STM32 Duino, and then we can proceed with that. So if you want to get your hands dirty as soon as possible, I'll link the video somewhere in the top right. Then comes, okay, so what are the hardware options you can purchase in order to follow along with the series? To follow along with the tutorials, I would recommend get one of the board like Discovery or Nucleo board, which are M4 or M3 based microcontrollers. You need not to buy these two specific boards. I will list down all the variety of boards that you can buy at your own convenience. And I would suggest if you want to purchase something cheaper, then go for the Nucleo board, as Discovery board comes a bit expensive. All right, it depends upon the area where you live in or the country where you reside. Next thing, these microcontrollers don't come with the cable, that is USB A to mini B cables, that you need to connect it with the host. I recommend you to purchase that as well. They do not come in the box. Well, we'll be doing a lot of examples and projects where I will be briefing you with the concepts and letting you know the basics. But I recommend you to follow some additional resources as well in case you want to have a deep dive into them or you want to refer them in future. So first of all, let me discuss with the books. The first book I will recommend is Mastering STM32, which is a very good book and a step-by-step guide to the most complete ARM Cortex-M platform. So it is being explained using Eclipse IDE. You need not to worry, you can also follow because STM32 Cube and Eclipse are quite similar. Then the next one is for understanding the microprocessor. It is the definitive guide to the ARM Cortex. All right. If you don't want to know the concepts, my video series will help you out understanding the basics and get started with your project. But in case you want, I have given you the links. Well, we have to also download the documents by the manufacturer. Those are nothing but the reference manual and data sheets, which we'll be using quite frequently. All right, let's wind up the video. No, we are not going to end it. So we are going to clear our prereqs. Let's first install STM32 Cube IDE and the MinGW toolchain. Then we will proceed on to create a C project as well as a STM32 project in the Cube IDE, and we'll try out our Hello World program both on the microcontroller as well as your host. That's the computer.
All right, so let's first install the required softwares. First of all, you need to go to the ST Microelectronics official website. Then you need to search for STM32Cube ITE, and you will get that in the product section. To somewhere get software, and then we want to install the latest version. Okay, so you need to click get software. You need to click on accept agreement. Then you will be required to fill up this form and log in and register. Then after filling your details, you will get a link or to download the file on your email. All right. I have already downloaded this, so I won't download it again. But let your download finish. Then wherever your download is placed, come to that location, and yeah, this one is mine. All right. So you need to unzip it. After you unzip it, you need to click on the application to install it. I did not prefer to extract it already. All right, we have this prompt, and we're gonna click yes.
The installation wizard is quite simple. You can easily follow along with that. Keep the settings as default and just click next. If you want to change the path, you can, or leave it as default. So I won't waste time on that. You can do it.
Right. So when it is installed, click OK and finish. Then, as I said, you also need to install the GNU compiler, and for that, we would go to mingw gcc, and I will keep the downloading in the description box below. So this is mingw minimalist GNU for Windows. You have to download this. All right. So I have already downloaded it somewhere here. Yes, you can find it like this. MinGW get set up. You need to click install, open it, click install, and keep the installation directory as C MinGW, not change it. Then click continue, and it says that the application is already installed. So I would like to reinstall to show you guys. So it's going to take some while as it is going to update the MinGW tool. So it says that installation database has been updated. Click on continue. Then it will lead you to this page. As you can see, the star marks indicate that I have already installed them. All of them will be unchecked. What you need to do is right click, mark for installation. Okay, you need to do for developer toolkit, MinGW base bin, GCC ADA, G++, leave the Fortran, and objective, and again mark the base bin. All right. So I won't do this because it will take a lot of time. So have patience and click here on apply changes. It will start installing the software. All right. Then what we need to do is after installation, we need to add this to our environment variables. So write environment on Windows search bar, then move on to environment variables below. When you click it, go to new. All right, click on path and get new. Then we will add our path where we have installed MinGW. So it's C MinGW bin. All right, it's important to include the bin as well. So click on new, enter the address, and OK.
All right, once we have installed MinGW, what you're going to do is let's check out whether it's properly installed or not, and it has been added to the path. Go to the command prompt by typing cmd in search bar and click GCC. Yes, it shows GCC fatal error. It's actually right. It has identified GCC. It is showing error because we have not provided any file to compile it. Okay, the STM32 Cube IDE icon looks like this. Click on it. It will open up your IDE. So we need to create a workspace. It is nothing but a folder where your files will be get stored. So I will create a workspace for the tutorial on the desktop itself. So what I'm going to do is I'll go to browse and I'll go head on to the desktop. Then I will create a new folder. I'll name it as STM32 tutorials. All right. So hit enter and select this folder. So this will be your workspace. So let's launch it. All right. This is the menu which you are going to get when you first open up the IDE. So it says welcome to STM32 Cube IDE. Here you can see it's your wish, you can read the documentation of the Cube IDE or go through the getting started with the Cube IDE wizard, which will guide you through the basics of the IDE. But let's go to file, click new. So first of all, we'll create a C or C++ project. Let's see how it's created. So we'll select the C managed build. You can also go with the C++ one. Click on next. All right, we have this meangw GCC in the toolchains. We need to select that, and it's going to be a empty project. Don't worry about that. Give a suitable project name. I will give it as hello world. Don't give spaces. It won't accept space. All right, finish. This is the C file. This is the IDE. This is the file which we created. Hello world. So what are we gonna do is that we'll right click on it, go to new, then we'll add a source file to it. We'll name it as main.c. All right. So let's include our library and let me type the hello world program. All right. So how we can compile it? First of all, go to the project explorer, right click, come down to build project. As you can see that from the C file, the object file has been created and a Windows executable file has also been created here. All right. So here we can see the binaries icon, which confirms that we have created the executable file. Right click on that, go to properties, and you can find the location where it is located. Let's go to that location by clicking on this icon. Yes. Double tap on to execute it. Here we have the hello world program. It is waiting for to take a character and it will close itself because of the get car function. All right, so we have written a hello world program on the host computer and it is quite similar if you have used any other IDE like Visual Studio Code. But what are we here for is to execute it on our microcontroller. Okay, right click on the project explorer, create a new project. All right, so we will be creating a STM32 project. It's initializing the STM32 target selector. All right, when we have this wizard, go to the board selector, write your board name STM32F407. All right, F4 discovery. This is my board, and you can identify it here. All right, so if you type in the nuclear board, it will also show it up to you. So click on next. Once you have selected your board, click on next. Then comes the project name. We will give only hello. All right, so the target language is C. It's executable, and don't keep it as STM32 cube, keep it as empty for now. It's important to keep it as empty, then finish.
Alright. I'm so sorry to interrupt you like this. We will continue with the STM32 project creation, but before that, I would like to introduce to this microcontroller or the board you have. There needs to be some prerequisites cleared before we head on to creating this project, and link to those videos, the Hello World and the Blinky LED program are somewhere here. And that's it for the video. Hope you like this, and don't forget to like, share, subscribe.